Okay, couple more topics using this whole net ionic, complete ionic molecular formula equation, but with two new twists. Just the terminology. When I ask you to do an acid-base neutralization reaction, it means that you're going to have an acid and a base, and you're going to have salt and water as the products, okay? And then we'll also do one with gas formation. So let's do this one first. Sulfurous acid plus potassium hydroxide. Let's go ahead and write down the molecular equation for this. Again, you're going to need to know your formulas that you learned back in chapter 2. Remember when we talked about all the acids, how to name the acids, what are the formulas of the acids? Sulfurous acid is different than sulfuric. Remember how we said that the sulfate becomes sulfuric acid, then the sulfite becomes sulfurous acid. So sulfurous acid is H2SO3, okay? And potassium hydroxide is KOH. All right, when you have an acid and a base, then the products are going to be a salt and water. All right, what salt are we going to be producing? The potassium is going to hook up with the sulfite to form potassium sulphite as our salt. So K2SO3, and then the H and the OH are going to hook up to form water. Okay, then you go back and you balance it properly. We have 2 potassium, so we're going to put a 2 here. That gives you 2 hydrogens, 2 hydroxides will give you 2 waters. Always think of water as HOH. You can balance it much better if you think of it that way. If you have 1 H and 1 OH, you'll get 1 water. If you have 2 H's and 2 OH's, you'll get 2 waters. Okay? All right, so this is the molecular equation or formula unit equation. Now let's start to break it apart in order to create the complete ionic equation. Now, sulfurous acid, is it one of the 6 strong acids? No. So what do? We leave it intact. So H2SO3 aqueous. It's still soluble in water, but it does not separate out completely into ions. It does not dissociate into ions. Potassium hydroxide, on the other hand, is one of the strong soluble bases, so we definitely split that up. So 2 potassiums and 2 hydroxides, because that 2 represents everything in here. Okay, what about the potassium sulphite? That is a salt. It is a soluble salt. How do we know that? Because anything that's got a group 1A in it is always soluble. So, and potassium is a group 1A. So take 2K plus SO3 2 minus. This is aqueous, also aqueous. And then what do I do with the water? We just leave it alone. Water is not considered a strong electrolyte, so we just write 2H2O liquid. Okay, so that's our complete ionic. How do I turn it into a net ionic? Anything that appears on this side and this side exactly the same, you cancel. So you cancel the 2 potassiums with the 2 potassiums. You rewrite this, and it's H2SO3 aqueous plus 2OH minus aqueous will give you SO3 2 minus aqueous plus 2H2O liquid. Okay, there you go. Let's do this one, and then I just remembered one more that I want to show you guys. Okay, so what if you have this next one here? It says copper 2. I'm going to erase this. You have copper 2 carbonate, so you need to write down the formula. Again, for those of you who have not studied your polyatomics, it's about time. You should know these, or else Chapter 4 exam is going to be not fun at all. All right, so copper Roman numeral 2 carbonate is CuCO3. How do I know that? Well, carbonate is CO3 2 minus. Copper could either be +1 or +2. This one says 2, so this is +2, this is -2. That's copper 2 carbonate. and then I'm going to add HCl. Okay, what will my products be? Well, cation hooks up with anion, so CuCl2, CuCl2, right? Because this is the cation, this is the anion. Copper is +2, chloride is -1, CuCl2. All right, so what do I have left? I have an H and I have a CO3. H is +1, CO3 is -2, so I'm going to need two H's, so H2CO3. Okay, great. This you should recognize as carbonic acid. Is carbonic acid one of the 6 strong acids? No, it isn't. But it does something unique, and this is why I wrote here neutralization reactions, and I wrote gas formation reactions. This is actually an example of a gas formation reaction, because anytime you have carbonic acid as a product, it actually decomposes to form carbon dioxide and water, and you see bubbles. Okay, that's the gas that's being produced. This has nothing to do with electrolyte or non-electrolyte. This is not a strong electrolyte. So it's not like it's breaking apart into ions. It's just decomposing to form carbon dioxide gas. So we're going to rewrite this as a complete ionic equation and rewrite this as producing the gas. All right. Copper 2 carbonate. Carbonates, if you look at your solubility guidelines, so not soluble at all. Carbonates are not soluble. So we're going to write CuCO3 solid. Okay. Unless the carbonates are hooked up to group 1A, and copper is not group 1A. HCl, strong acid. Let's break that guy apart. Oh, you know what, guys? I did not balance. Shame, shame, shame. Gotta always balance. Don't forget to balance before you do everything. So I just caught myself, which is, thank goodness. All right, good. Break this one apart. So I've got 2 hydrogen ions and 2 chloride ions. So 2 hydrogen ions, aqueous, plus 2 chloride ions, aqueous. All right. What about copper 2 chloride? Chlorides are all soluble unless they're hooked up to silver, mercury, lead. Copper is not silver, mercury, lead, so it is soluble. So it's a soluble salt, so we break it apart. Cu2 plus aqueous plus 2Cl minus aqueous. Now here's the new part. This carbonic acid is not going to be broken apart into ions, right? But it decomposes anytime, and I'm going to say it one more time, anytime you have carbonic acid, H2CO3, as a product, it will always decompose to form water and carbon dioxide. So we'll say water liquid, carbon dioxide gas. Okay, so now how do I turn this into a net ionic? Well, anything that can be canceled that is exactly the same on both sides, I think it's just the 2Cl minus, 2Cl minus. So we'll get rid of those two guys, and we end up with this. CuCO3 plus solid, so this is solid, plus 2H plus aqueous will give you Cu2 plus aqueous plus H2O plus CO2. Okay, there's the gas formation that I put as a heading here, and here's your little bubbles that you will be observing. Okay, so before I move off of this topic entirely, I just wanted to show you one more thing. Let's say you had something like this. Let's say you have sodium chloride reacting with, let's say, potassium nitrate. Okay? And you wanted to do a molecular equation, complete ionic equation, and net ionic equation. All right? So you do your products over on this side, metathesis reaction, double replacement. Your sodium hooks up with the nitrate, so NaNO3 plus KCl. I made it nice and easy, perfectly balanced, no big deal. Okay, so that's your molecular equation. Turn it into a complete ionic. So anything that is considered a strong electrolyte, obviously you break apart into ions. So we've got Na plus Aq, because sodium chloride is a soluble salt, plus Cl minus Aq. Why is this a soluble salt? Because it's got a group 1A. Potassium nitrate has group 1A and nitrate, so definitely soluble salt. Aq, strong electrolyte. NO3 minus Aq. Okay. NaNO3, same scenario, nitrate soluble, sodium soluble, so Na plus aqueous plus NO3 minus aqueous. And then finally KCl, potassium, group 1A, yes, soluble, so K plus aqueous plus Cl minus aqueous. Sorry, it's so jammed up. Hopefully you can see. Okay, that's my total ionic. Now I cancel everything to get my, or cancel whatever is the same on both sides to get my net ionic. So that's what I'm going to do. My sodiums cancel, my chlorides cancel, my potassiums cancel, my nitrates cancel. So you see in this scenario that everything cancels. And when that happens, then you write no reaction. So there's no net reaction. When all the ions, when everything is in ionic form in the solution, no gases are being produced, no precipitate, nothing is insoluble, nothing is not a strong electrolyte. Then, and all the ions cancel. Then, if this is a multiple choice test, you would choose no net reaction. Okay, when everything cancels. Good. In the next video, we will move off of this subject and we'll start talking about oxidation numbers and redox reactions. Okay?